important topic in our industry right now. And I say eliminating, the reality is we will never totally eliminate it, but we're going to certainly work on reducing that bias. Now, let me ask a very simple question here, right? If we use math instead of humans, do we eliminate bias? And I hope most of you will agree that the answer is no, that is not true, right? I would argue that we reduce bias because humans have generally more bias than machine learning algorithms, but machine learning algorithms do not make the bias go away. And in fact, the bias in machine learning is usually sourced from humans. So what I want to do is talk about how do we, recognize this bias? How do we manage the bias? What are the implications of this bias? There's a great book that I would recommend for all of you to read if you are interested in this topic. It's called Weapons of Math Destruction by Cathy O'Neil. She describes the importance of transparency in the algorithms that we use for AI and concerns about bias, which she calls, basically bias embedded in code, right? So algorithms have a very high impact on people's lives every day. They make decisions related to whether we get a mortgage or not. They make decisions based on what movies are recommended to us, what products are recommended to us. Many different dimensions of our lives are impacted by these machine learning algorithms. And the problem is they're like a black box to us. And inside that black box, there can be bias, and we need to be very conscious of that bias, and we as practitioners in this field need to manage that bias. So these algorithms are biased. There are more than 180 different types of human biases, and many of them have actually been transformed into our AI algorithms. Not on purpose. I'm not saying that they're on purpose. It's definitely not the case. But these AI solutions that we're building have pitfalls of reinforcing social biases in humans related to race, gender, sexuality, ethnicity, and this is a problem. The World Economic Forum published a report that suggested that lack of transparency and bias in AI algorithms would be the #1 inhibitor to widespread adoption of these algorithms. This is a very important field that's been emerging over the last several years as we start to see these algorithms proliferating. In the academic world, which I originally came from, the Association for Computing Machinery created a working group called FAT, Fairness, Accountability, and Transparency in Machine Learning. And this working group studies bias in deep learning and looks at the techniques for how do we reduce, ideally eliminate, but let's say reduce that bias in its impact in humans, in our population, in our society. In California, where I live, we have something called CCPA, the California Consumer Protection Act. In Poland, you are under the umbrella of the EU, so there's GDPR, the General Data Protection Regulation. And in these regulations, and there are many others for different countries and even down to different cities, bias is actually against the law. If there is bias detected in your algorithms, which discriminates against people for giving them loans or the recommendations that you make, etc., there is a regulatory fine for that. That can be a lot of money depending on the size of your business. And yet, it's easy to write a law onto the books. Enforcing that law is much more difficult, right? How do you detect when there's bias? It's as if we need AI solutions to monitor the AI solutions for bias, but who is monitoring the AI solutions who are doing the monitoring, right? So we get into this circular problem. We need to use technology to understand the bias, but we need to also understand the limitations of that technology. My claim is that the mathematics in the AI algorithms are not inherently biased. Math is not biased. It's actually the data that you use to create the AI algorithms, the data that you use in the training sets that are used to derive the mathematics, that's where your bias typically exists. So when we're looking for bias, it's important that you examine your data supply chain for the training. Now, when you're looking at that data, there are many different characteristics that are important. So for example, is that data of sufficient volume so that you have statistically relevant representation of all the communities that your algorithm is meant to serve? Let me give you a specific example, which is actually very ironic. There is a machine learning algorithm on Nikon cameras that looks at the picture that you took, the digital picture that you took, and detects if the person in the picture is blinking in the picture or not. And if they're blinking, then the camera is actually going to prompt you, hey, photographer, the picture you just took, at least one person in the picture has their eyes closed during the picture. Do you want to retake the picture? So this is a very useful feature. Ironically, Nikon is a Japanese camera manufacturer, but the algorithm has bias in determining or recommending to retake the picture on Asians who have a different eye shape than Western Europeans or North Americans, because the training set, even though the camera is manufactured in Japan, the AI algorithm for blink detection was actually done in Silicon Valley. At least that's my understanding of the original source. That might have changed by now. And the subjects used in the training set were largely North Americans. Of course, we have Asians in North America, but there was not statistically enough sampling done of Asians so that the algorithm actually is not performing well relative to Asians in the population. So in this case, the training data did not have sufficient representation for all the populations that should be included. And this is recognized in many different scenarios. Even, for example, there are companies that have used machine learning to screen resumes to decide which candidates they should bring in for interview or not bring in for interviews. And in this case that I'm referring to, in a particular industry which had historically been biased by humans to hire males over females, the training set, which were the resumes for people that they had hired successfully, had a bias towards males, and therefore there was a bias in the algorithm that screened out females that were perfectly qualified to take the job. So this is a problem in the algorithm. Now you might say, oh, but it's not a problem because I'm a smart data scientist. I'm not going to include gender as one of the features in my training set. And so if gender's not there, I can't be biased against male versus female. Well, it turns out that just excluding a feature isn't enough because the algorithms are very smart. They will pick up correlation of other variables to race or gender or religion and so on. I can tell by your clickstream data whether you are black or white. I can tell by your clickstream data whether you're male or female. I can tell by your clickstream data whether you are Christian or Muslim, right? So there is data which is not explicitly representing a community that can essentially be used to correlate and introduce bias. So be very aware of these effects. In order to minimize the impact of this, you should use stratified sampling and observation weights that are optimized so that the different communities within your training set are represented in a fair way. You should be analyzing for missing values in your data set. And if there's systematic bias aligned to particular communities, that can introduce bias in your training. It's very important in order to reduce bias that you standardize processes and create templates for model documentation deployment. The more you standardize, the less opportunity is there for human bias sneaking into your models. Now, I know data scientists don't always like standardization. We say, oh, no, data science, it's an art, it's creative, and so on. Well, data science, it's called science for a reason. It should be repeatable and it should be auditable. Right? So standardizing processes is very important. And you should have a team that is going to participate in the audit, a challenger team that is going to validate the machine learning algorithms, because the team working on the algorithm, they have what's called confirmation bias. They believe that they built a good algorithm, and they want to believe that they built a good algorithm. And it's important that they have confidence in their work. You need a team who's not part of the build team to independently validate the machine learning algorithms to make sure that there's not bias. So you need to take the output of the algorithm and understand if there's bias in the false positives and false negatives that is oriented to the different communities that you are serving in your machine learning algorithm. There are different places where bias can be introduced into the solutions. I'm mainly focused on the data, and I think that's where the biggest opportunities are, but it can also be on framing the problem. So for example, let's say that I'm making a music recommendation engine, and I'm using machine learning for that. Well, what is the objective of that music recommendation engine? You might think it is to recommend the best song that I'm going to appreciate at this moment the most. And maybe, music when I wake up is going to be different than music on a Friday night. And, I have my own preferences for music and so on. That might be what you think is the recommendation goal. But in fact, if you are the streaming provider for music, your goal might be to provide music that I like to listen to, but it might also be to minimize the licensing cost for that music. And so you might be recommending me my second or third choice of music because my first choice of music actually had a higher licensing cost. It's important that there's transparency. So when you're making recommendations to someone, you understand what is the objective of the recommendations. GDPR requires that the objective be transparent for these algorithms. That's part of the law. How you collect the data, if I decide in my music streaming that people should not listen to music with bad words in it, profanity. I don't want people using vulgar language. So as the data scientist, I'm going to train the data. I'm going to create the training data set. I'm going to exclude all songs that have bad lyrics in them. I have now made a censorship decision and embedded it in my AI algorithm for recommendations. And so by virtue of excluding data from the training set, I have biased the algorithm against music that has vulgar language in it. And, a data scientist should not be the one to be the censor for music. Now, again, it's your recommendation engine. If you're transparent, then maybe that's okay. Maybe that's a feature, but you should be transparent about it, right? How you prepare the data, how you transform the data, these are all very important factors. I believe you should have an algorithmic audit for your company. You should audit the definition of success. Again, the music I most like to listen to versus the licensing costs. Those are conflicting definitions of success potentially, and you need to understand how those are weighted. You need to audit the data and make sure that the data is up to date, that it's got a statistically significant representation for the different populations that you're serving, that you don't have systematic bias and missing values, that the accuracy of your predictions is not biased. So you take the performance of the model and you analyze and you create the confusion matrix, which includes false positives and false negatives, and you look at those relative to the different communities. If you have a lower false positive and false negative for white males than black females, then you might have a problem. You probably do have a problem in the bias of your model, so you want to pay attention to that. So there's good news and bad news, right? It's great that these machine learning algorithms have learned how to emulate humans, but the bad news, they've emulated some of the bad characteristics of humans as well. They've emulated the bias that humans bring to the table that have seeped into the algorithms. The good news is that we can understand and manage them. We can build algorithms that provide transparency, explainability. They're open source software available out there like Shapley that you can use to create transparency. And there are algorithms that you can use to measure the predictive accuracy and make sure there's no bias in the predictive accuracy of those models. So the bottom line is we're not going to completely eliminate bias, but we can proactively manage the bias and minimize its impact on our society by taking these steps within your organization. So my recommendations in conclusion are, first of all, standardize the approach for developing and deploying machine learning. If you don't have standardization, it will be very hard to properly manage proactively and monitor for bias in your organization. Identify prejudices that exist in the processes, especially as it relates to collecting and processing the data, right? And so where are you getting the data? If that data is from historical sources that are reflecting historical human biases, you've got a problem. You may need to recollect that data or get it from different sources. You may need to augment that data. If you're processing the data and transforming the data in a way that is biased to a community, for example, by treating missing values in a systematically biased way, you're going to get into trouble. Test for unwanted bias that's going to be embedded in the algorithms by constantly monitoring the performance of the model across different communities. Invest in explainability. Of course, I know that we want our models to be more and more accurate. I'm a big believer in that, but if you can't explain why the decision is made to a consumer or a decision maker within your organization, then the model is not going to be as fully useful as it could be. So, you know, that explainability is very important. Challenge the assumptions. Embrace the auditors and the challenge teams within your organization and you know, incrementally deliver capability with machine learning. So don't take the most highly regulated scoring models as the first shot. Use recommendation engines before risk scoring. So with that, I thank you very much for spending this time with me this afternoon. Dziękuję bardzo, and please email if you have additional questions. Dziękuję bardzo.